Hello, everybody. Today we're going to be looking at our last section of our chapter of right triangles and trigonometry. And we're going to be tying everything together. So first, let's look at our agenda. Today is Wednesday, the 25th. Your job is to watch the agenda video for March 25th, complete the warm-up that is posted to Google Classroom, and watch the Law of Signs notes video. And then finally, you will complete a Law of Signs My Math Lab. All this is due by midnight, and email me if you have any questions. All right, one thing I want to note before moving on is you're going to need your graphing calculator today. I know some of y'all do not have a reliable calculator at home, so I wanted to point you in the direction of this site. It's called Desmos.com, and it provides you a nice online feature for your calculator, especially to use those trig functions. If you type in the Google calculator, it doesn't pull up a calculator that's capable of using sine, cosine, tangent, as well as those inverse, but Desmos does have those features. So if your calculator's not reliable, you're more than welcome to use that website. All right, so let's dive in. Law of signs. Throughout this whole unit, we've looked at relationships such as special properties of right triangles, or special properties of 30, 60, 90 degree, of 45, 45, 90. We've looked at Pythagorean theorem. We've looked at trig ratios. And then today's this final stepping stone. So law of signs shows the proportional relationship between angles and their sides. And the nice thing about law of signs is that it can be used on any triangle. So all the previous relationships we've looked at, those were specifically for right triangles, meaning they had a right angle within it. Today, we're going to be looking at a relationship that can be used in oblique triangles. So that's a triangle that does not have a right angle. And we're going to be we're going to be bringing back a little bit of that relationship of proportions from similarity. So at the bottom, I have an example, kind of to come up with our formula for law of signs, and it's going to be showing that relationship of opposite angles and opposite sides. So if I'm going to set up an extended ratio, on the top of my first ratio, I'm going to have sine of A all over side A. That's going to be equal to sine of B over B, and sine of C all over side C. This relationship is consistent for opposite sides and opposite angles. And in order for us to use law of signs, we have to have one of these ratios. So I have to have a quantity for an angle and a side. It doesn't have to be, or it can be any side. So I could have my relationship between angle A and angle side A, angle B and side B, or angle C and side C. And I could set up this ratio between two sides, all sides, and it can be any two sides. We just have to have a ratio between an angle and a side. And how do I know what measures pair up with which? It's all going to be opposite. So let's look at example 1. We're going to use the law of signs to set up a proportion and solve for x. So if you notice, I already have a couple of markings. I am going to use sine of angle 71. My opposite side is x, equal to sine of 35, come on, all over 12. Now, when I first went through this unit with honors, a couple questions they had was, how do I know what measures to use? Well, it's going to be the measures and the evidence that's available to you, and it has to be a consistent ratio. So I chose 71 over x because it was my angle and side that are opposite. 35 and 12 because that was my angle and side opposite. If I knew this angle and this side, I could also set that up equal to this to solve for x. It's just kind of whatever evidence is available to you. Another question I got was, well, how do you know whether to use sine, cosine, and tangent? Well, this is the law of signs, so you will only be using signs. Now it's a matter of plugging and chugging and cross multiply. just as you would in proportions. So that gives me 12 sine of 71 equal to x sine of 35. To get x by itself, I'm going to divide by sine of 35. Divide by sine of 35. And now it's a matter of plugging into your calculator. So if I were you, I would type in 12 sine of 71. Make sure your calculator is in degree mode. So that gives me 11.3. I'm going to hit divide by sine of 35. Remember, it's very important when you're using trig ratios to kind of let your answer ride. Don't round too early. Don't round until the final step to get an accurate answer. So for my final answer, I got 19.78. And we're going to round to the 100th place. And that's what is x? X is going to be that side value. It's that side measure. So law of sines can help us solve for side measures as well as angle measures. Let's look at another side measure. So I'm wanting to solve for x. So if I were going to set up a relationship, I would have x on my bottom. Well, I need to know this angle measure. Okay. Do I have a ratio between an angle and side that I can set this relationship up equal to? Well, I have 58 and 25. So I could set that equal to sine of 58 all over 25. The last step is I need that angle measure that's right here. How am I going to find that? Well, I have a triangle. I have two side measures. So I can take 33 plus 58 gives me 91. 180 minus 91 gives me 89. All right, so that's my angle measure. So I'm going to take sine of 89 over x equal to sine of 58 over 25. I'm going to cross multiply. So 25 sine of 89 equal to x sine of 58. I'm going to divide by sine of 58, divide by sine of 58, and I'm going to solve for x. So 25 sine of 89 gives me 24.99. Hit divide by sine of 58. That gives me x is equal to 29.47. And that is that side measure. All right, let's look at it if I do not have an angle measure. Remember with trig ratios, when I wanted to use a trig function, I did not have an angle measure. What method would I use? The inverse. We're going to use the same properties here. So I'm wanting to solve for this x value. So I'm going to have sine of x all over my opposite side, which is 15, equal to whatever ratio I have. Well, I have the ratio between 126 over 31. So now it's a matter of cross multiplying. So I get 31 sine of x equal to 15 sine of 126. I'm going to divide by 31. Divide by 31. I have sine of x equal to 15 sine 126 divided by 31. Remember when I take the inverse of angle, I switch my side measure and my angle measure. So I'm going to take the inverse of sine, 15 sine of 126 divided by 31 is equal to x. Now it's a matter of plugging and chugging. So I type in 15 sine of 126 divide by 13. Second sine, second answer gives me my angle measure of 68.98. we are going to get more practice doing the law of sines. Today we've covered the most basic format of using law of sines for angles and side lengths. Just remember, when you use angle measures, you want to use the inverse value. If you guys have any questions, please let me know. At this point, you have completed your agenda video, you've completed your warm-up, and you've completed your notes video. Your last step is to complete your My Math Lab assignment, and all this is due by midnight. Email me if you have any questions, guys. Have a good day.